Hi and welcome to another interesting video. I'm Success is my name, and in this video tutorial we're going to be covering the question, the old rumor which is actually around the internet about talking about current, voltage and resistance. I'm actually getting a lot of rumors on YouTube, and I've got a lot of rumors on Facebook and different of arguing on what actually cues. Is there actually the voltage or actually the current or the resistance? What actually matters? What actually makes electricity to shock you? Like when you touch a electricity main supply, like an AC voltage, when you touch it with your bare hands, why do you get shocked? Is it actually the voltage, the current, or the resistance? What actually matters? I'm going to cover that in this video, and I'm going to explain it better for you to understand in your max understandable knowledge. So do all to stick around to the ending of this video to get the great insight and full tutorial. As I said, I'm Successful is my name, and let's go into the video. Now, just as Electro Boom actually said, I actually got the inspiration from Electro Boom a lot because of its educational electronic content. But just as Electro Boom actually said, Electro Boom actually said the voltage is actually what actually makes you to get shocked. I agree to that, and I understand why other people actually disagree. Other people actually said that the current is what matters to you to get shocked. Yes, everything is important. The voltage is important, the current is important, and also the resistance is also important. Everything is important to get you shocked. Nothing is exempted, and without a particular thing, you're not going to get shocked. Now, here's the question: what actually gets you shocked? Is it actually the voltage, the current, or the resistance? Now, the correct answer, the simple answer to this question is the voltage. Yeah, the voltage is not the main thing that actually gets you shocked. The current is the main unit that actually gets you shocked. But without the voltage, there is no current. Without the current, there is no shock. So without the voltage actually picture this. Now picture this as the voltage, as the pressure. Now let's picture this in a water. Let's picture it in a water flow, like a water tank flow. Now in a pipe as you're given, the voltage is actually the pressure of the water, while the current is the amount of water which actually flows, but the resistance is actually the size of the pipe. So without enough voltage, there is no current, and without enough current, there is no shock. You won't get shocked without the voltage. Now picture this: if you have 1 volt and you have a power supply that is actually producing 1 volt, and you have the power supply actually producing over 100 amperes of current, you will not get shocked if you touch that main supply. Like if you touch the output of the power supply is actually produce about 1 volt and 100 amperes of current, you will not get shocked because there's not enough voltage to actually get you shocked. The voltage is actually what pushes the amount of current to go through your body. So if there's a low voltage, there's no enough pressure to push in current into your body, thereby you will not get shocked. And also resistance also matters. Lower resistance, high rate of shock. High resistance, you get a tiny shock, but it's still dangerous. Remember that all what I'm saying in this video is actually educational. It's not actually good to do it in a practice way, and you just want to test it out. Please don't try it at home. It's just for educational purposes and to understand about electric current and how it actually flows. Now you're going to be wondering, you're going to be asking me this question: successful electronics is, why do I say the voltage is responsible for pushing the current to go through our body and get shocked? Yes, the voltage is actually the pressure which actually pushes the current. Actually, as I said earlier, the voltage actually what pushes the current, and the resistance is also important because with low resistance we're going to get high shock, and with high resistance we're still going to get shocked, but it's not as massive or severe as when you have a low resistance. I'm going to explain for you. Now, using the Ohm's law, calculating for current is actually equals to voltage divided by resistance. Now, let me say we have a main supply, we have a power supply producing 1 amps and over 100. Sorry, have a power supply that's actually producing 1 volt and over 100 amps of current. Now, we use the Ohm's law, which is actually current, I equals to voltage divided by resistance. Now, the voltage is actually 1 volt, and the resistance of our body, depends on how we are. Like, say, if we are actually sweating, if we have a sweaty skin, if our body is actually moist, the resistance is actually going to drop. But if our body is actually dry, the resistance is going to be high. Now, let me say, for instance, let me just assume that our body in a dry state is actually 10,000 ohms, and our body, when it's in a wet state, is actually 1,000 ohms. Now, in a dry state, we are going to put it in a value 1 volt divided by 10,000 ohms, which will give us the value of 0.1 milliamps. So yes, we are going to have only 0.1 milliamps flow through our body, which is really tiny and really not going to fit anything. But if our body is actually moist, our body is actually wet, our body is actually moist, like let me me say sweat and stuff like that, our resistance is going to drop drastically to 1000 ohms of resistance. This is not actually the main one. I'm just giving an assumption because of this video. So putting it in the formula, we're going to say current actually equals to 1 volt divided by 1000, which should come to a value of 1 milliamperes. So yes, 1 milliampere is actually more than 0.1 milliamperes. So yes, more resistance, you're going to get less shock, and low resistance, you're going to get more shock. So everything comes together. The voltage is important, the current is important, and also resistance is important. The voltage depends on how much current flows through our body. If you have a high voltage, less current flows through our body. But also the resistance is really important. Just as I said earlier, just as I calculated earlier, with low resistance you get high amounts of shock, and with high resistance you still get the shock, but it's not as severe as when you have when your resistance is low. Like if your resistance is high, your body resistance is high, you're gonna get shocked, but not as severe as when your resistance of your body is actually low. So the resistance also matters. Resistance is actually the size of the pipe, as I said earlier in this video. Resistance is the size of the pipe, the voltage, the pressure of the water, while the amount of water that actually flows is actually the current, which we actually explained earlier in this video. So yes, the voltage is important, the current is important, and the resistance is important. The voltage is the main thing. Without the voltage, there is no current flow, and without the current, there is no shock. So stop saying the rumors around, stop blaming, or stop taking the knowledge that current is the main thing that actually gets you shocked and gets you killed. Yes, current is actually the thing that actually gets you killed, but without the voltage, there is no fucking current. Get that in your head.
Looking at the calculation which I actually did earlier, I actually calculated for how much current is going to flow through your body if there's actually a power supply that is actually outputting 1 volt and over 100 amperes of current, and we calculated about 0.1 milliamperes and 1 milliamperes, which is small and which is enough to tell you that without voltage, with a low voltage, there is not enough pressure to pushing current through your body, and you won't get shocked if there's not enough voltage. So that is why I just clarified that using the Ohm's law formula, using a power supply that is outputting 1 volt and over 100 amps of current. And also you should understand the knowledge that voltage is the main thing, because if you check in all these electric fences, you can find a written on it which says high voltage. If the current is actually the main thing that actually causes the shock to happen to you, they are actually going to write high current, stay away, stay alert, but they actually wrote high voltage. So that is enough to tell you that the voltage is the main thing. The voltage is the subject that actually pushes the current through your body and gets you killed.
Now earlier in this video, I actually said the voltage is actually responsible for pushing current through our body that actually get a shock, and I said that without the voltage there is no current, and without the current you will not get shocked. Now calculating for the amount of current that actually flows through our body, we actually need the value of a resistance, and we actually also need the value of volt. As I said earlier, I actually said if you have 1 volt and 100 amps of current from a power supply, you won't get shocked because there is not enough voltage to push enough current. So 100 amps of current produced by a power supply, does it matter? It's actually the voltage actually matter. Now put it in the calculation, we actually say calculating current in Ohm's law, using Ohm's law value, calculating current is actually equals to voltage divided by resistance. Now let me assume that our body is actually 10,000 ohms of resistance. Our body is actually 10,000 ohms in a dry state. We are not actually wet or sweaty or stuff like that, and we have a 1 volt. I actually said that the value is going to be 0.1 milliamp of current, which is really tiny and really not really good. You're not really going to feel anything. But if you have over 230 volts and you have your body state is still 10,000 ohms, you're going to be saying 230 volts divided by 10,000, which is a popping value of 23 milliamps, which is really dangerous and can get to your skin and actually kill you. So you have to get this in mind. You don't have to touch mains supply, because mains supply actually have a whooping value of about 230 volts, and that 230 volts can push enough current to go through your body and is eventually going to kill you. And you're going to be understanding the rumor. I'm going to be clearing the rumor that touching the ground and touching, you know that for current to actually get to your body, for current to actually flow through your body, it actually needs a pathway. You have to be on the ground. Yeah, one part of your body have to be touching the ground, and your hand or your body is going to be touching the main supply, which actually probably going to get you shocked. Now you're going to be wondering, another question which I'm going to be asking, you're going to be wondering that if I'm actually floating in the air, or if I'm actually perfectly isolated from the ground, am I still going to get shocked? Yes, you're still going to get shocked. Probably still going to get shocked. You're not going to get really severe shock as when you're touching the main ground, but if you're still like isolated, this is some kind of boot or stuff like that, you're still probably going to get shocked, because AC actually is is actually different from DC. DC is actually a direct current, but AC is actually alternating current. Alternating current actually flows through the air. It can flow through the air, and kind of if you're kind of sweaty or stuff like that, it can act as a capacitor and still go to get in contact with you, and you're still going to get shocked. So you're not perfectly not going to be getting shocked if you're fully isolated from Earth. You're still going to get shocked probably, but you just have to be careful, and you don't have to test it out. I was thinking of testing it out for you guys, like touching the main supply and isolating myself from Earth and see if I'm not going to get shocked. But since I'm dealing with AC, it's still probably going to get through something, because the air is actually moist with water, and it's going to pass through that air moist in my body, because it's actually AC power supply. It's actually acting, our body is actually acting as a capacitor with the air moist, and if we are still probably going to get shocked. But maybe if it's a kind of direct current DC, not really going to matter that much. But yes, you're still going to get shocked if you're perfectly isolated from ground. You just have to be careful, and you don't have to try this at home. I'm still going to be making a video about explaining AC and DC, to explain the main theory and how to understand it very well. I'm still going to be making other videos which relate to this subject, so stay tuned to that. And I hope you really get the main insight that voltage is actually what pushes the current to go through our body, and resistance is responsible on how severe we are going to be getting shocked. There's also a rumor that you're kind of see a bird standing on an electric wire, on a high tension electric wire, and they're not getting shocked, they're just safe. I'm going to be explaining that. That will be in a different video, and that will be a really fun topic to explain and analyze what is actually happening. So I hope you really enjoyed this video. If so, don't forget to hit the like button, subscribe to my channel, and also to be notified, you need to click the notification bell. You can also support on Patreon. You can join for free. That will be in the link in the description. You get behind the scenes and also channel updates and video updates on what is actually coming up. So yeah, I hope you really enjoyed this video and get the full breakdown tutorial, and I hope I answered your questions. If you're kind of confused, let me know in the comment section below, and I'll answer to you. Be okay. Thank you very much for watching. I'll see you in the next one. Peace out.